All right, number six. Number six, by the way, is really, 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 really spicy. It doesn't look spicy. I don't know. Number eight's not, but number six is. So I just want to mentally prepare you here. Number six is rough. Okay. Plus two. Divide by three. You guys good so far? So plus two divided by three. Okay, now this is where the spicy part comes in. So square root. Okay, and really carefully. So the squared and square root cancel. Whenever I square root both sides, I have plus or minus square root of 11/3. Okay, so this negative 11/3. This there's still a lot of work to be done here. You think like that's the answer. That is not the answer. Okay, the first thing I'm going to do is fix the negative. So I'm going to say x equals plus or minus I root 11/3. Okay, and that is also not the answer. Yeah, okay. So you cannot leave a square root in the bottom. That is not proper final answer. How do you fix it? It's called rationalizing the denominator. And you did it last year with the 30, 60, 90 triangles. You multiply by a giant 1 made of the denominator. Okay, so the top becomes root 33 because those two multiply, and the bottom becomes root 9 because those multiply. Yeah. And then the bottom simplifies to be 3, and now you don't have a root in the bottom. That's the answer. No, it's a lot, but I'm glad we're starting to remind you about how that works. It's a lot. Spice. I mean, it could happen. That's not on there. That's not, this topic isn't one of the topics, but we are going to talk about that in a second. Okay, write expression in exponential form. So this problem really is just asking you to rewrite it back to this. So the type of root is the denominator. So first you do 6v, whatever's in the root goes in parentheses. And the type of root it is the denominator, and the exponent is the numerator. That's it. Yeah, that one's preferable for sure. Okay, now can you find the homework from the weekend, please, which was the quiz review? Okay, what questions do you have for me from this? Yes. Or, okay. Is it order of operations or the describing, or what do you need help with? Okay, so first, A is -2, H is -5, and K is 0. Does that make sense so far? Okay, so A is a reflection across y-axis and vertically stretched by a factor of 2. Okay, so that's the negative is the top bullet and the 2 is the bottom bullet. And then the H is -5, so shift left 5. And then you don't have to do anything for the 0 because 0 is how it usually is. Okay, but do you know how to graph it? Okay, table. Did you go down to? Okay, I see what you did. I see what you did. Any other questions from this? Yes, honey. No, but the A value, if it's positive, it opens up, and if it's negative, it opens down. I just circled one of them after I found A at the end. Okay, so just to be sure, everybody read this up here with me, please. X squared is 1/6. No calculators for 15 minutes of class. And one of each of these. Identifying each of a parabola, describing the graph transformations and graphing using 5 points. We just talked about that. A equals H equals K equals shift left, vertical drive, blah, blah, blah. And then for me, when I like to graph using 5 points, I'll make a table and I'll put the vertex in the middle and go down to and up to and then plug in things into the original. You know what I'm talking about? Okay. Writing the vertex graphing from equation of a parabola given the vertex and the point. So you just have to plug in HK, plug in XY, solve for A, and then write the answer. The equation is the answer. And then write triangle trigonometry, which is the sine, cosine, and tangent problems. Okay, are you wondering how to do that without a calculator? You're just going to end at x equals like 14 times tan 26. That's going to be your final answer. Then you go until you like would do the calculator. Yeah, exact form. Okay, you see what I mean? You're just gonna like set it up and then get X. Yeah. Okay. Scooch this guy off to the side and find this guy. We're gonna work on this for the next 2 days. This is one of those things that, you know how I tell you to leave your packet at home after the chapter? This should stay in your binder or in your folder all year. Okay. I am going to use 2 colors of pen and a straight edge. So just so you know, I'm going to use 2 colors and a straight edge. Got the yellow one. Nice. Are you guys ready? I have no more time for you now. We need to move on. Okay. First, we're gonna do each column separately. We're gonna start with parabolas because that's where your base of most of your knowledge is. The family name is quadratics. Quadratics. And the general equation, this is super important, a x minus h squared plus k. Okay. The locator point for a parabola is called the vertex. And that is the point h comma k. And parabolas do not have asymptotes. All right, now what I find is easiest to do to fill out the bottom two, I find it's best to do our sketch first. So I'm going to go to 0, 0, and I'm going to attempt to draw my nicest parabola. And this would be the regular style of parabola, meaning no transformations. Okay. All right, now end behavior. This is the first time that you're learning about end behavior, so you need to go really careful, slow here. This says, as x approaches negative infinity, which means that as x goes to the left, as x goes to the left, y is going, and so what you do is I just label my arrows, both of my arrows are going up. So this is saying as x goes to the left, y is going up. And this bottom one is the right arrow. So the left arrow is going up. The right arrow is also going up. So negative infinity up, positive infinity up. Practice writing your infinities. Mine are just little 8s on their side, like 2 circles smushed together. I just can't seem to do the actual infinity symbol properly. Okay. For parabolas, the domain is all real numbers. It's all real numbers for all parabolas. You don't even have to think about it. Every parabola has the domain all real numbers. Okay, however, the range depends on if you have a positive a value or a negative a value. Because if it's a positive a value, it opens up. And a negative a value opens down. Ours is positive here, but we're actually going to write a formula. Y is greater than or equal to k if it's a positive a, and y is less than or equal to k if it's a negative a. So now you actually have a formula for domain and range. You can just find your k value and plug it in. Okay, now what we're going to do, and we're going to do this on every single one, grab your other color. we're gonna draw it with these transformations. So we're gonna put A, H, and K in. One second. Okay, so I want you guys to see, here's the blue one and here's the red one. So figure out where 3, 4 would be. So like here. No, no, no. No. Yeah. And then you want to make it steeper because of the 2. Thank goodness I'm living in the land of erasable pen. Okay, so notice it was shifted up 4, right 3, reflected across the x-axis, and then 2 times steeper, so vertically stretched by a factor of 2. How's yours look? Is it better than mine? Probably. It's probably better than mine. Okay. Next column. Y equals x cubed. These are called cubics. Cubics. Okay, and the really great thing about doing the parent graph summary is that the equation is the exact same thing, except it's cubed. Have you guys ever graphed a cubed before? I didn't think so. Okay, now cubics, they do not have a vertex. They have what's called an inflection point. Which is also HK. And cubics do not have asymptotes. Okay, as I said, I like to fill out the top 4 boxes, then make the sketch after that, because that helps us with everything else. And here is x cubed. So it's just like a parabola, but it's a little bit steeper because they're cubing, and then this side is negative because the cube of a negative is a negative. Okay, so come down here. Do your best. Okay, and do you guys see what I mean by inflection point? So inflection point means it's going up, 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 and then it flattens out and then it starts to go up again. That's what I mean by inflection point. So it's that flat part. Interesting. Okay. All right, now end behavior. So this arrow is going down, so I'm going to put negative infinity. This arrow is going up, so that's positive infinity. You see the difference between that and a parabola? Okay, so the top line says left. As I go left, y is going down. As I go right, y is going up. Oh man, they didn't even connect on that one. We're good, we're good. And my favorite part about cubics, the domain and range are all real numbers no matter what. Okay, so what I want you to do is take your pen and try to make 3, 4 at the same spot you made 3, 4 in the last one. Just do your best. Okay, and then here is what it looks like. So it's flipped. It's going to come down the opposite way and be even steeper. And then write your equation with the cubed. Are you guys starting to pick up what I'm laying down? That was the first time you've ever probably done cube though. Okay, what are these called? Yes. Okay, this is not the time to blow this off. Seriously, do not. Please concentrate. Okay. So what's going to happen here in the absolute value is going to become the parentheses, and there's just no exponent. So it goes in the same order. Y equals A, X minus H inside the grouping symbol, plus K. So you see how the A is on the outside, X minus H, and then plus K on the outside. Okay, these have a vertex. Do you remember what these look like? Yeah, they're V-shaped. No asymptotes. Okay. All right, now we're gonna sketch it. It looks like this. Violet just said the most insightful thing. Parabola and absolute value have the same end behavior and the same domain and range because they're basically taking up the same amount of space. So as I go to the left, I'm going up. As I go to the right, I'm going up. Domain is all reals. And the range, again, it depends on if it's opening up or opening down. Okay, and then there is the transformed one. So try to find that same spot. And then notice it's going to be steeper. Because of the two. Yeah. So it flips it and makes it steeper. Okay, and last thing, y equals -2 x minus 3 plus 4. Okay, flip over, find the exponentials when you're ready. Nope, I was kidding. Okay. All right, now exponentials are weird. The radicals and rationals will get back to the usual. Exponentials are a little bit spicier. And you probably haven't, when's the last time you graphed an exponential? Math 1. Did you do them in math 2 at all? Yeah, okay. You got the idea. Okay. So A is still in the front. B is the base of the exponent. X minus h this time is in the exponent. And then the plus k is outside. I know, I know. Okay, the locator point is also weird. HK is on the asymptote. So you can't really use that as your locator point. So you use H comma K plus A. And you might remember these are the first time you learned about an asymptote in Math 1. Yeah. Aren't you glad we're putting this into a thing that you can look at? Definitely. Okay, so here's the thing. There's actually 4 different possible transformations because of B. We're just going to use a B of 2 because it's just, we have to pick something. So here is what 2 to the x looks like. So what I'm going to do is put B equals 2 right here in the corner of my sketch. Okay, this is might be the most challenging question we've had so far. Okay, I'll ask this first. What is this arrow doing? Going up. Okay, beautiful. Okay, so that means that the right arrow is going toward infinity. If you have a positive A, this is a positive A, it's going up. Okay, hardest question so far today. What is this arrow doing? It's not going down. Okay, what is it doing as far as up and down go? Okay, never hitting 0, right? It's approaching the asymptote is what I mean. It's getting closer and closer and closer to the asymptote, but not touching it. So it's actually approaching K, which is the asymptote. That's really hard. Domain is all reals because it goes forever left and right. That's not a big deal. The range is y is greater than k, not equal to because of the asymptote, it doesn't touch. And y is less than k. All right, so let's look at one of those. Okay, so here's the transformed one. What I want you to do is go to 4, whatever 4 was for you on the other side. It's like here. Make your dashed line for your asymptote. Other color, yeah. And then put 3, 4 actually on the asymptote. It's not on the curve, it's on the asymptote. So there's your -2, your 3, and your 4. Really? Anybody need more time? Okay. We're not doing them all. I would like to finish this page and that would be it. Then we have one tomorrow. We have imaginary numbers notes and a digital escape, which is really fast. But I would just like to do these 3 and then I'll be done. Okay, these guys are the ones that you made the posters about, which there's a couple of them still left up over there. General equation, y equals a. A's in the front still. The grouping symbol is a square root, so x minus h plus k on the outside. If you remember, these have an endpoint, which is hk, no asymptotes. Trust me, you're going to have this paper out all the time. Okay, what does a square root graph look like? It's like half a parabola on its side. Okay, so let's do the end behavior for a positive A. That's what we have here. It's really weird. So do you see how this doesn't have an arrow? That means there's no end behavior to the left. End behavior means like at the end, like far away. This stops, so there's no end behavior. What's this arrow doing? Up, yep. Does anybody remember how the domain and range looks for these? X is greater than or equal to H. And that's for all of them, but there's a difference for positive A. Notice it's going up, so the range is Y is greater than or equal to K. We'll look at the negatives once we graph one that's negative. We'll see how that looks. Okay, so find 3, 4. Same 3, 4 you've been finding all period. Okay, now let's look at end behavior. Look at the left side. Is there an arrow? No, so still none. What about the right side? Up or down? Down. And what about the range? Going down, so less than or equal to K. Beautiful. Thank goodness you're here. Okay, I'd like to do one more and then we can be done. That leaves us with only one to do tomorrow, so everything else will be easier. The other two are later in the chapter, so. Okay, anyway, last one. Does anybody remember what this guy is called? We did that first chapter, chapter 1. Rational function. Thank you. And the equation is y equals a's in the front still. 1 over x minus h plus k. And I want to write an or here because you can actually sometimes see it as a over x minus h plus k because somebody multiplied the a times 1 and put it on the top. Those are the same thing. But sometimes the a's in the front and sometimes the a's in the top. All of you guys that were wondering, like, what happens when it's in the other like spots? Now we're gonna answer that question. Okay, do these have asymptotes? Yes. Okay. So the locator point is where the asymptotes cross. And the vertical is at x equals h, and the horizontal at y equals k. Okay, this is what it looks like to remind you. Okay, now take a look at the exponential over here. What is the left arrow approaching? The asymptote. And what is the right arrow approaching? The asymptote. And do you guys remember how to do the domain and range for this? Yep. So this is our last sketch. I want you to find me the point 3, 4. And then we're going to make the asymptotes cross there. Okay, now here's the moment where you were wondering, when do we graph them in the other quadrants? This one's a -2, so it will be on the top left and bottom right. And the 2 is supposed to make it even closer to the asymptotes, but it's really hard to sketch that. Yeah. Yeah, just one second. I just want to make sure. Do you guys all know what the homework is? CPM, right? 4 questions. Okay. And then you guys all know there's a quiz on Wednesday at the beginning of the period. 3 questions. We discussed it. Okay. Thank you. Yeah, Ben, go ahead.